This is Geometry 3.2a. We're talking about algebraic properties and proofs. So here we have a list of properties that's true about algebra. Additional property of equality. It's a very simple statement. It's a very simple concept. You already understand the concept. When you add the same thing to both sides of an equal sign, you're going to keep it equal. So if you have A equals B, like I have as much money as you do, then if we add the same amount of money to both our amounts, we're still going to be equal. This is just what we call it when we add the same amount to both sides. Subtraction property of equality. That's when we subtract the same amount. Multiplication property of equality. That's when we multiply the same amount to both sides of the equal sign. You got to pay attention to when you do that, but this is when you're doing it. This is what it would be called. Now, distributive, this is division. Division property of equality. This is a weird one because C cannot be 0. So what we're talking about is C being, no we're not. We're talking about A being divided by C and B being divided by C. So if you have two amounts, let's just go back to that analogy of the amount of money I have and the amount of money you have is equal to each other. A equals B. And if we divide our money by the same amount, we should both have divided it and have now the same amount. If you take 10 and divide it by 2, you're going to get 5. If you take another amount, which is the same as 10, and you divide it by 2, you would still get 5. Right? Substitution property of equality. If A equals B and B equals C, this is going to sound like the transitive property also, but it is just the property of equality. Substitution property of equality. Look at the B value. Here's A equals B. B also equals something else. So I'm going to take this something else and I'm going to plug it in place of the B. This doesn't happen a lot in algebra problems, but it will happen as we're setting up, especially with some geometry problems. But if we plug the C in place of the B, because that's what B is, it's C, sounds funny, A equals C. That's a substitution property. Distributive property. Now this one we're not going to use the word equality on it. You can scribble that part out. It doesn't really fall underneath equality. If we look in the textbook, you'll see examples of properties of equality: addition property of equality, subtraction, multiplication, division property of equality, and they even consider substitution property to be part of equality. I question that one also. But over here, they do have division property as being a separate property. It's not falling underneath addition. It's not falling underneath equality, because it doesn't happen on both sides of an equal sign. It doesn't require an equal sign like this would require an equal sign to subtract the same amount from both sides. This is just the concept of multiplying through. It's going to be the same as if you had AB plus AC, because you're multiplying it in. You're distributing it in. That usually only happens on one side of an equal sign. We'll talk about the proof stuff here in a moment. So let's slide on down. Let's give this a try. Determine the next steps. And what is the reason? That's really what we're doing. What is the reason? It's not an if-then statement. What is the reason that we're going to give for this step? What would we do to solve for x? Just algebra. Just think algebra. We would divide both sides by 2, and that would give us 5. So the property we would use from the list that we've talked about up here, the property that's called, of course, pretty simple, division. Property of equality. You got to get used to writing the words. We're going to write much longer statements in the future, so writing these 4 words should not be overly challenging. Try not to get frustrated by that. Just take your time, division property of equality. What goes on with letter B? Somebody new. We would subtract 7 from both sides. And that would give us x equals 5. So you could call that subtraction property of equality. So be careful. Some people look at this, they see the plus 7 and they say this is addition. No, you're adding the same amount, and actually you're subtracting the same amount of 7 to both sides. That's the new step. You're subtracting, you're not adding. You're subtracting the 7. How about letter C? What do you see about that? So because 3 is the denominator, we're going to multiply both sides by the denominator. We're not adding anything because we're not subtracting anything. It's not subtraction property. So to get rid of this 3, which is dividing the problem, we have to multiply. So that's called the multiplication property of equality. And then our next step from there is to get rid of the 2. So next we're going to divide both sides by 2. Notice that we don't have to show all the work. You don't have to show the minus 7 divided by 2. You don't have to show that. We're kind of showing our steps by discussing what the multiplication or what the property of equality is. In this case, we got x equals 6 because we did the division property of equality. Be sure to write all 4 words, at least for today. We'll talk about shortcuts in the future. Letter D. Now, there's probably more than one way to do this one. But what do you think that we could do? How could you be creative with this one? The distributive property gets multiplied over. And we add the 6. Oh, wait, hang on. I got all carried away. I wasn't thinking about what I was doing. I was just solving. So we did the distributive property, so we're going to write that. Distributive property. And remember, this is the one that we said we didn't need the of equality part. Okay? We don't need that part. No big deal. Now what do you see? Now what would you think? So next we would be moving the 6 across. If you would like to show a little +6 and a +6, you're welcome to do that. But for the first time, probably in your mathematical career, you don't have to show your work. That's kind of the neat part of this. You're showing your work by explaining where you got the 2x plus 10. What did you do to both sides? You did the addition. Property of equality. And that created the 2x equals 10. And next we would be dividing. So we divide both sides. So that's called the division. Property of equality. So we started out with 1 steps, then we actually went to a 2-stepper, and this time this was a 3 steps that it took us to work through that problem. Real simple. We totally understand when we distribute or when we add or subtract. So this shouldn't be too hard. What we're actually working on is what a proof looks like. This is more of a proof format. Students usually say that proofs are the toughest things that you do all year. So we're working first to do proofs with something you're confident about, algebra, and then we'll work our proofs into some geometry topics that you might not be as comfortable about. So from the top, we learned that a proof is an argument that begins with a known fact and proceeds through a series of logical deductions and ends with the thing you're trying to prove. In this case, we're just trying to get x by itself. That's what we're trying to prove. How do we get x by itself? We're going to do our proof using a 2-column format. 2-column proof. You always have 2 columns, one for the statement, 1 column for the statement, and 1 column for the reason. We're doing 2-column proofs. There are actually proofs called flow proofs. Your book has flow proofs in it. Your book has paragraph proofs in it. But we'll always use 2-column proofs when doing our assignments. So, now you see that you have this big T, and that's just making your 2 columns. You label one of them statements, the other one reason. And we start to create our proof. So we're looking at this reason. Or what we're trying to solve is right here. We're going to call that our first statement. We have to start somewhere. So you always put what we're going to work with first, so that makes life really easy. That's kind of called the given information. You got to start somewhere. So that's our given. Now we think about the different algebra steps that it takes to get x by itself. You sometimes have choices. Like we can move the 3 or we can move the x. Your choice. I would suggest to move the x to the other side. I like to keep my x's positive, so I'm going to bring my x to the left. If you would like to write it real lightly, if you would like to do that, you're welcome to, but you don't even need to do that. You just need to be sure you have your calculations correct. Some people make a mistake and they call it 1x, but it's actually 3x. And what did I do? When you show your work, you can really see what you did. You got to pay close attention. But you added the x to the other side. So your second reason here is addition, property of equality. what would be our next move? What's our next step that we do? We would move the 3 over. Subtracting that would give us 6. So our reason for that would be the subtraction property of equality, because we subtracted the 3. And somebody new? What's our last step? You see the pattern going on?
Divide the 6 by 3.
By dividing to both sides with the 3, we get a 2. And we call that, gotta use the right word, division property of equality. Pretty clear. So we go over here to our next problem. Our last one will do. This one has a few extra steps in it. So let's discuss here. It has something we haven't done yet either, so you really got to pay attention to this one. Our first statement is always what we're trying to work with, what they give us. Okay, have a hard time getting it to fit, but if it crosses the line lightly, that's all right. And what's that reason again? So that's our given. Now, what's the first thing you might want to do? You probably have more than one choice, but there's things that we can do. Somebody willing to be brave, maybe someone who hasn't said anything yet. We could take the 3 and multiply it in, or better terminology would be to distribute. So it's 3 times x and 3 times 5. We still have the 2x equal sign and 21 plus 10x. And that's the distributive property of equality. No, we don't say equality for that. Silly. We just say distributive property. All right. So what do you see next? Tell me what you might think about. So for number 3, we do have a few different choices. We could move the 15 over. That's one option. But a lot of people might agree that they would move these two together. The positive 3x and the negative 2x are going to create 1x. And then that gives us 15. We've already used the 2. 21 plus 10x. And what that's going to be called is what we exactly just did. We collected like terms. Collect like terms. Don't mistakenly call that addition property. Okay, because we're not adding anything. We're not even subtracting anything. We're grouping these numbers together. This is positive 3x's. This was negative 2x's. Together they create 1x. So next, some people might move the x's together. It doesn't matter if you move it to the right to keep it a positive x. That's what I typically like to do. I just get nervous moving it to the right. I would rather have x's on the left. So if I'm going to keep x's on the left, sometimes it helps you to make your little marks so that you're sure to make the right response. This ends up being -9. Then you still have the 15, and you still have the 21. So that was the subtraction. Property of equality. Now we would probably add the 15 across. Statement number 5. 36. And that was the addition. Property of equality. And finishing up with the last one. Somebody want to share what our last statement's going to be? So we're going to divide both sides by the -9. That would give us -4. Notice in our reason, notice this, that we don't give the detail. We don't say we added by a certain amount, or in this case, subtracted the 10x. We don't say that we added the 15. Here we don't say we divided by a -9. We just say division, property of equality.